Lesson 6.2, and we are studying the properties of exponents. Please take a moment and copy down the top portion of these notes. All right, let's continue, and I'd like to go over these rules, just kind of review them with you, and then we'll do some examples based on them. First, you have to know what a power is. When I say that word, you're referring to something that has this appearance. The A is representational of the base. It's written in normal font, so to speak, so normal size writing. The M is the exponent, and that is usually, that's a superscript, and it's written in a smaller size. All right, so this is a representation that says that we're multiplying by the base A m times. M just tells us how many factors of A we have. So a quick example would be if we had 2 to the third power, that means I'm multiplying by 2 3 times. 2 times 2 times 2. All right, so this is a shortcut for representing that multiplication. All right, so if I am multiplying, so our first rule is if we're multiplying the same base, and we have m factors of A and n factors of A, how many total factors of A do we have? We have the sum of them, m plus n. And so this is the product of two powers is equal to the sum of the exponents. Okay, so now let's look at rule 2. We have a quotient. I have the same base again, so this will have to match, but we're dividing them. So this rule says that we can subtract the exponents. But you do see that there's two versions of this. And the reason for that is that we do try to avoid negative exponents. And if m is smaller than n, when I subtract them, I'm going to get a negative exponent. It's not a bad thing. We do have Rule 7 that will help us deal with negative exponents, but we try to avoid them. So the way I manage this is I think about which of these two is the larger number, and I subtract from that. All right, so if m is larger, I use this rule. And if n is the larger, I use this one. And then what it's saying is that wherever the larger exponent is, that is where your final power will be. So n larger, my power will be in the denominator. And m larger, then my power will be in the numerator. Remember, this is over 1. So that is a numerator answer. Okay, rule 3. All right, we have a grouping symbol. We're multiplying some stuff inside of it, and we take it to a power. Well, you have to distribute that power. Everything inside, even if there were numbers inside, would get that power. 4. I am dividing different things inside of a grouping symbol and power outside. You have to distribute that power again. Both of these relate to distributing the power. So everything inside, numbers, variables, whatever is in there will get that power. And so you see that here we distributed it. Rule 5. All right, this is a power, and it's taken to a higher power. So that means that we're going to multiply the exponents. That will tell us that we have m times n factors of A. Rule 6. What happens if we get a 0 in the exponent? Anytime that happens, this simplifies to just the number 1. It doesn't matter how complex that is. So I could have something like 463x to the 5th power, and then I take that whole thing inside a grouping symbol to the 0 power. Well, all of this just simplifies to 1. That's a little different than saying something like this, 463, and then x to the 5th to the 0 power. The only thing that goes to 1 is this portion of it. So this part right here is just 1. So I have 463 times 1, which is 463. All right, so you just have to pay attention to what has the 0 power. And then rule 7. All right, this is how you deal with negative exponents. When we simplify powers, the answer should never have a negative exponent, so you have to deal with this. All right, so here is a power with a negative exponent. I am going to rewrite it with a positive exponent, and the way you do it is by taking its reciprocal. So I'm going to essentially think of this as a whole value, move it down below, and the whatever coefficient was up here, right now it's a 1, is what you see here. Or vice versa. What if the negative exponent is in the denominator? I take its reciprocal. So this is essentially going to move up here and I end up with a positive exponent. All right, let's put these into practice. All right, some examples. We're going to simplify. That means no repeated base. So if you have a times a anywhere in your answer, you are not done. No negative exponents. All right, so keep those two rules in mind, and let's begin. Example A says 3 squared times 3 to the 6th power. Well, what does that most look like? We have this like bases, both are 3's in our problem, and so we're using this rule. We're going to add these exponents. So this simplifies to 3 to the 2 plus 6. And then you simply add those and you are done. So 3 to the 8th. And that is our answer. All right, so we have like basis. Again, -4, but this time we're dividing. All right, that looks like rule number 2. Now I know there's parentheses, but the parentheses are limited to the -4, which is including the negative in the power. All right, so -4 to the 2nd, -4 to the 7th in the denominator. What's the rule going to be? It says subtract the exponents. But remember when I talked about this, I picked the bigger number. So m or n, which one's bigger? Well, 7 is bigger. So I'm going to use this rule. I'm going to keep my answer down here and subtract from the 7. All right, so what's in front here? What's the number? This is an invisible 1, so that's what's going to stay on top. And then I write -4. And then I subtract 7 minus 2. And then we just simplify that. And that's -4 to the 5th power. Now you might say, well, you said no negative exponents. Well, we don't. That 5 is the exponent. Remember, -4 is the base. We can have negative bases. That's okay. In fact, what this means is, and there is a way to simplify and get the grouping symbol off. It's just you have to understand that when you take multiple powers of negative numbers, sometimes it's going to stay negative and sometimes it'll stay positive. And here's how you know. All right, I'll just at the bottom of the paper just kind of go over this. If I take -4 to the 5th power, that means -4 times -4 times -4, 5 times, right? Every time I have two negatives and multiply, I end up with a positive number. And then here, 2 more negatives. If I multiply these together, I end up with a positive number. But I still have this remaining negative. Right? Again, multiply 2 positives, that's still positive. This one is still negative. And if I multiply a negative and a positive, I end up with a negative. So every time I have an odd number of factors, my answer will be a negative. And so this would end up being -4 to the 5th power, and it would be written like this. It's as if we're multiplying by a -1 here in front, maintaining that whatever 4 to the 5th is, there's going to be a negative in front. How is that different from something like -4 to the 4th power? -4 times -4 times -4 times -4. If I have an even number, every pair of evens is going to cancel the negative, so those two cancel each other out. These two cancel each other out, and so I have nothing but positives, and so this will end up being +4 to the 4th. So we can tell by the exponent, if it's even, we're going to cancel all the negatives. If it's odd, there'll be a leftover negative. And so I can further simplify that problem we were just working on. Take off the parentheses, which is always the best and final answer. It's odd power, so that negative will stay, -4 to the 5th. And that would be my final answer. All right, so the next one. So you want to recognize what it looks like, compare it to one of these rules. We have a power that inside a grouping symbol, and we're taking it to a higher power. So the rule says, keep the base, multiply the exponents. So this would be c to the 4 times -3, which is -12. Now that is a negative exponent, so I now have to deal with that. And that is in the numerator. This is over 1. So this is in the numerator. So I'm simply going to move it down below. I'm going to keep on top the coefficient, which is, there's nothing, you don't see it, but it's an invisible 1, so we keep that there. And so my final answer will be 1 on top And z to the negative 12 goes on the bottom as a positive power, z to the 12th. All right, next example, D. All right, so again, I have x and x. We have the same base, so we're going to use rule 1, and that means add the exponents. So this is x to the 9 plus negative 9. Well, that adds up to 0. So this is x to the 0. All right, so x to the 0 means that I'm going to use rule 6, and that simplifies to the number 1. And we're done. All right, here we go. E. All right, again, same base, but I want you to notice this is not in parentheses this time. So this is no different than saying negative 1 times 5 to the 8th over negative 1 times 5 to the 4th. And these, negative 1 divided by itself is going to be positive 1. All right, not in parentheses, then we do not take the negative to the power. All right, so now we just have to do the power rule. I notice I have the same base, and the power rule we'll use is number 2, same base. I have to subtract the exponents when I'm dividing. The bigger exponent is on the top, so we'll keep it the bigger one on top, so it's going to be 5 to the 8 minus 4. What goes on the bottom? Well, just the number 1. So essentially, since it's a whole number, we don't write it. My final answer will be 5 to the 4th. F. I have a power to a higher power. There's lots of negatives, but I'm going to begin with looking at rule 5. I'm just going to apply it and first multiply the two exponents. And I'm thinking ahead a little bit. I know if I multiply these two, I'll get a positive power, so I don't have to deal with rule 7. All right, so this would simplify to 6 to the negative 2 times 5, negative 2 times negative 5, which is positive 10. And I'm done. All right, so let's try a few more. All right, we're squaring this, so that's negative. We're going to square, this is the rule, let's see, which one was it? Rule 3. I have some things inside of a parentheses I'm multiplying, and then I have an exponent. I'm multiplying inside this, in example G, I'm multiplying negative 1.5 times y. Those are different bases. So the rule is, from that rule up here, we're going to distribute the power. All right, so that means negative 1.5 squared and y squared. And the only thing is to simplify this. 1.5 times 1.5 is 2.25. Negative 1 times a negative times a negative is a positive, so this is positive. And y squared doesn't simplify, and there's our answer. Typically with small powers, we actually multiply out the value. All right, here's the next one. I have a quotient. The bases are different. I have a base of a and a base of negative 10. My exponent is 3 on the outside of the grouping symbol. So that reminds me of rule 4. We haven't used this one yet, but it's just distribute that exponent. So m is going to be distributed to both bases. So let's start with that. I'm going to take a to the 3rd power and negative 10 to the 3rd power. All right, a cubed won't simplify, so we keep that the same. But negative 10 cubed. Okay, so just one more time. Let me find a little space down below. If I take negative 10, it is in the grouping symbol, and I cube it, that means I'm going to have 3 factors of negative 10 times negative 10 times negative 10. Again, I have an odd number of negatives. My answer will end up being negative. And then 10 times 10 times 10 is 1,000. So negative 1,000. So my final answer is a cubed over negative 1,000. Last example. Okay, again, I have 2 times x, and then I'm dividing that by 3. So I have a quotient, and I have a product, and all of that's being taken to this power. Now I do see the negative, so I'm going to show you a way to deal with the negative first. In this example, I could distribute that -5 to everything, as rule number 4 says to do. It's really a combination of rule 3 and 4, because we do have a product in the numerator and we have a quotient as well. So in any case, we have to distribute. However, I can deal with that negative first. All right, so negative means take the reciprocal. So I can take the reciprocal of this whole fraction, and that negative will go away. This becomes 3 over 2x to the positive 5. All right, so everything inside flips because everything inside has that negative power. So I take the reciprocal, and now let's distribute the 5. And so that gives us 3 to the 5th power over 2 to the 5th power, and x to the 5th power. No negative exponents. Now I'm not going to expand these out. I will just leave them in power form. And that's our final answer. All right, it is time for you to crack open the textbook and go to practice 6.2 and do some of your own practice.